How to factorize a quadratic. Here we will be modeling on the most general form. In a previous video called Quadratic Formula Derivation, I looked at how we expand a binomial expression. When we have a binomial expression squared, here we'll be going backwards from that with our quadratic to see if we can factor that into two binomial terms. Just a review. The most general form of a quadratic is given by ax squared plus bx plus c, where a, b, and c are elements of R, and a is not zero. Otherwise, the quadratic reduces to being a linear form, bx plus c. But typically, a, b, and c are elements of the counting numbers or of the integers, z. Now, if a is greater than 1, so for instance, we have 9x squared plus something, and we can factor that down, what we will typically find is that we don't have we don't have roots which are elements of the counting numbers or of the integers. They will more likely be rational expressions like P on Q. So for instance, you can see that I've factored down algebraically to dx plus e times fx plus g. Now to find the roots of that expression, we want to set it equal to 0, which means the first term is 0 or the second term is 0. So if the first term is 0, then dx plus e is 0, so x equals minus e on d. So unless d is a factor of e, then straight away one of our roots is irrational. So be aware of that when we have a greater than 1. So here are some examples, 4 of them, looking at factorizable quadratics and looking at what the roots are for them. So we'll start off with x squared minus 4x. So as you can see, x squared minus 4x cuts the x-axis at 0 and 4, and that makes sense because we can factorize this into x minus 4. And if we set that equal to 0, either x is 0 or x minus 4 is 0. So 0 and 4. Next example, x squared minus x minus 2. Well, by inspection we can see straight away that we can factorize that into x plus 1 times x minus 2. Now, if we want to look at the roots of that, we can see that that crosses the x-axis and is equal to 0 when either the first of those factors is 0, x plus 1 is 0, or when the second is 0, x minus 2 is 0. So it yields x is equal to minus 1 and x equals 2. So up to now, all of our roots have been integer values. Let's look at the next example. 9x squared minus 25. Well, that's a difference of 2 squares. So the square root of 9x squared is 3x, and the square root of 25 is 5. So this factorizes into 3x minus 5 times 3x plus 5. Now if we look at the roots of that, the first one is 0, which gives x equals 5 on 3. The second one is 0. X equals minus 5 on 3. Now we have roots which are no longer integers. So let's look at the last one. Minus 8x squared plus 6x plus 9. This happens to factorize, and it happens to factorize into 4x plus 3 times 2x minus 3. Again, looking at the roots, if we set the first to 0, we get x equals minus 3 on 4. If we set the second to 0, we get x equals 3 on 2. So again, we have non-integer roots. Time for examples. So we've got 5 examples here. So we'll start with the simplest, x squared plus 7x plus 10. Here, our coefficients, a, b, and c, are equal to 1, 7, and 10. Second example, 2x squared plus 5x plus 3. Here, a equals 2, b equals 5, c equals 3. Third example, 12x squared plus 17x minus 14. Now in this example, it's not so easy to factorize this on inspection because 12 has multiple factors and so does 14. Here, a equals 12, b equals 17, c equals minus 14. Fourth example, 6x squared minus 27x plus 30. Again, multiple factors. A equals 6, B equals minus 27, C equals 30. Fifth example, 64y squared plus 4y minus 3. Here, A equals 64, B equals 4, C equals minus 3. Some revision about expansion. Remember the acronym F.O.I.L, F-O-I-L, first, outer, inner, last. So let's take the example x plus 7, x plus 4. Now, when we expand this factorized quadratic, we use the acronym F.O.I.L. First means the respective first terms, x times x, x squared. Outer means the outer terms, x times 4, 4x. Inner means the inner terms, 7 times x, 7x. Last means the last two, 7 times 4, 28. So we have x squared plus 4x plus 7x plus 28, which expands to x squared plus 11x plus 28. Method for factorizing of ax squared plus bx plus c. 1. Multiply a and c. 2. List the factors of the product AC. 3. Identify the pair of factors that sum to give B. 4. Rewrite the quadratic, splitting B with the pair that we've found in step 3. 5. Factorize the two pairs of terms. Example 1. X squared plus 7x plus 10. A is 1, B is 7, C is 10. And everything is positive. A times C is 1 times 10, which is 10. Factors of 10 are 1, 2, 5, and 10. Now we're looking for a pair of factors that sum to give B, which is 7. So that would be 2 and 5. So now we can rewrite this quadratic as follows. X squared plus 2x plus 5x plus 10. Now, if we look at this, we'll note that we can factorize the first two terms. X squared plus 2x becomes x into x plus 2. And the last two terms, we can remove the 5, plus 5 into x plus 2. Now the common factor to the first and second term is x plus 2, so we can remove that, and we have x plus 2 times x plus 5. Example 2, 2x squared plus 5x plus 3. Here, the coefficient of the x squared term is greater than 1. So, a times c is 2 times 3, which is 6. The factors of 6 are 1 and 6, and 2 and 3. Now, looking for two terms which sum to a pair of factors which sum to give 5, that would be 2 and 3. So we split the quadratic as follows. 2x squared plus 2x plus 3x plus 3. Last step, we look to factor. So look at the first two terms. The common factor is 2x. 2x goes into 2x squared x, and 2x goes into 2x once. So 2x into x plus 1. And out of the last two terms, we can remove 3, plus 3 into x plus 1. Now the common factor to both of those is x plus 1. So x plus 1 into 2x plus 3. And if we multiply those together, using FOIL, F for first, we get x times 2x squared. X times 2x is 2x squared. O for outer, we get x times 3, 3x. I for inner, we get 1 times 2x is 2x. Adding those together, 2x and 3x is 5x, which gives the middle term. And finally, L for last, 1 times 3, it's 3. So we reconstitute the quadratic. Example number 3, a more complicated example because now we're dealing with negatives and positives. 12x squared plus 17x minus 14. A is equal to 12, B is equal to 17, C is equal to minus 14. Step 1, A times C is 12 times minus 14. Answer, minus 168. Step 2, list the factors of minus 168. Because we have a product which is negative, that means each pair of factors will be positive and negative. That is, and you'll notice that I've notated the factors with plus and minus signs. So the first there is plus minus 1. So, looking carefully, I'll go through this example, but not the next two. I have, if I look at the upper value, plus 1, and that matches with minus 168 at the end. Then I have plus 2, which matches with minus 84, then plus 3 with minus 56, then plus 4 with minus 42, then plus 6 with minus 28, then plus 7 with minus 24, then plus 8 with minus 21. Then, if I look at the bottom half of the signs, and I work back outwards, I have minus 8 plus 21, minus 7 with plus 24, minus 6 with plus 28, minus 4 with plus 42, minus 3 with plus 56, minus 2 with plus 84, and minus 1 with plus 168. Now, step 3, the next constraint is to look for the pair of factors that yields the coefficient b, which is 17, plus 17. So that would be minus 7 and plus 24. Step 4, rewrite the quadratic using this pair of factors. So that becomes 12x squared plus 24x minus 7x minus 14. Now, step 5, factor the quadratic. So if we look at the first pair of terms, what factors out of 12x squared plus 24x? Well, that's 12x. 12x goes into 12x squared x times, and 12x goes into 24x twice. So that's 12x into x plus 2. And of the last two terms, we notice that we can bracket them. So instead of having, without brackets, minus 7x minus 14, that becomes minus bracket 7x plus 14 bracket. So what can we remove from that? 7. So it becomes minus 7 bracket into x plus 2 bracket. Then we notice that what's common to both of those is x plus 2. So we have x plus 2 into 12x minus 7. And then reconstituting that using our acronym F.O.I.L, the first two terms, x times 12x, gives 12x squared. The outer terms, x times minus 7 is minus 7x. The inner two terms is 2 times 12x, 24x. Adding those, 24x minus 7x is plus 17x, which gives the middle term. And finally, the last two terms, plus 2 times minus 7 is minus 14, which gives the third and final term. Example number 4, 6x squared minus 27x plus 30. Here, a is 6, b is minus 27, c is plus 30. Now, step 1, AC, a times c is 6 times 30, which is positive 180. Step 2, look for the factors of 180. Now, the factors will be, the pair of factors will be both positive or both negative. And if we look at b, since b is minus 27, that means that the pair of factors will be both negative. So we have 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36, 6 and 30, 9 and 20, 10 and 18, and 12 and 15. And I've notated the signage with plus minus on each term, so we will be choosing the lower. So which two factors give minus 27? Well, that's clearly minus 12 and minus 15. So step 4, rewriting the quadratic using that pair that we've just found in step 3, 6x squared minus 12x minus 15x plus 30. Yeah. Now, if we bracket those last two terms, we can rewrite that as 6x squared minus 12x minus bracket 15x minus 30 bracket. Now, step 5, factor out. From the first two terms, what factors out of 6x squared minus 12x? Well, that's 6x. 6x into x minus 2. And what factors out of the last terms? Minus 15 into, again, x minus 2. Now factoring that, x minus 2 is common to both of those. So we have x minus 2 into 6x minus 15. And we can check that that's right by reconstituting it using FOIL. Multiplying the first two terms, x times 6x, 6x squared, that's the first term. Outer, x times minus 15, minus 15x. Inner, minus 2 times 6x, minus 12x. So minus 12x minus 15x is minus 27x. That's the middle term. And last, minus 2 times minus 15, positive 30. That's the last term in the quadratic. So looking at the same example again, what we might have noticed is that there is a common factor to the coefficients here. If we look at 6, minus 27 and 30, we might notice that 3 divides into these. So 3 is a factor of all three coefficients. Therefore, we can automatically factorize out 3, which leaves us with a simpler expression. So we have 3 into bracket 2x squared minus 9x plus 10. So now a is 2, b is minus 9, and c is 10. So, having had this simplified somewhat, we go to a times c, and we now have 2 times 10, which is 20. And because a times c, because c is positive in this equation, 10, that means the two factors are both negative, or they're both positive. And because minus 9, of course, is negative, that means the two factors must be negative. So looking at the factors of 20, we get plus 1 plus 20, plus 2 plus 10, plus 4 plus 5, or we get minus 1 minus 20, minus 2 minus 10, and minus 4 minus 5. So the next step is what plus what is minus 9? Well, that would be minus 4 and minus 5. So now we can rewrite the quadratic as 2x squared minus 4x minus 5x plus 10. Now we can bracket that, 2x squared minus 4x minus 5x bracket 5x minus 10 bracket. Now we can factor the first part of that, 2x into bracket x minus 2 minus second part 5 into x minus 2. Now we can remove the x minus 2, which is common to both parts of that. So we have x minus 2 into 2x minus 5 times 3, which we removed earlier. And then we can reconstitute that using FOIL. X times 2x, 2x squared. O for outer, x times minus 5 minus 5x. I for inner, minus 2 times 2x minus 4x. So minus 4x and minus 5x is minus 9x. And minus 2 times minus 5, positive 10. So we get 2x squared minus 9x plus 10 multiplied by 3. Here's our last example, number 5, 64y squared plus 4y minus 3. Here we can't factor out anything from the coefficients and constant. So a is 64, b is 4, c is minus 3. Step 1, a times c. 64 times minus 3 equals 192. Step 2, list the factors. Because 192 or minus 192 is negative, that means we'll have a mix of one positive and one negative factor. So again, I'm going to notate, and as I get halfway through the factors, the signs are going to flip upside down. So I have plus 1 minus 192, plus 2 minus 96, plus 3 minus 64, plus 4 minus 48, plus 6 minus 32, plus 8 minus 24, plus 12 minus 16, and then we flip to the lower half of those values, minus 12 plus 16, etc. So step 3, what plus what yields the coefficient of the y, which is positive 4? Well, that's 16 and minus 12. So step 4, rewrite the quadratic using that pair, 64y squared minus 12y plus 16y minus 3. Now since that sign in the middle is a plus, we don't need to introduce brackets here because the plus doesn't change whether we have brackets or not, unlike the minus sign. Now, the last stage, stage 5, factor out. What factors out of 16y squared minus 12y? 4y. 4y into bracket 16y minus 3 bracket plus. What factors out of 16y minus 3? Nothing. So that's plus 1 into bracket 16y minus 3. Now, out of both of those terms, we have 16y minus 3 factoring out times 4y plus 1. Now let's reconstitute that quadratic. First, 16y times 4y, 64y squared. That's what you can see above. O for outer. So FOIL first, O for outer. 16y times 1, 16y. I for inner, minus 3 times 4y. That's minus 12y. 16y minus 12y plus 4y. That gives us the middle term. And finally, L for last. Minus 3 times 1, minus 3 gives us the last term. So in summary, the method for factorizing ax squared plus bx plus c, if it is factorizable, step 1, multiply a and c. Step 2, list the factors of the product AC. Step 3, identify the pair of factors that sum to give b, whether b is positive or negative. Step 4, rewrite the quadratic splitting b into the pair of factors we found in step 3. And step 5, factorize that. So, just looking back at our example number 3, we had 12x squared plus 17x minus 14. A is 12, C is minus 14. AC is 12 times minus 14 minus 168. So the factors of that are listed below, and you can see up for the first half of the factors I have plus minus, and for the second half of the factors I have minus plus, because the corresponding positive value matches with the corresponding negative value to give negative 168. Now, which two gave the value of 17, positive 17 for B? Well, that would be plus 24 and minus 7. So we split that quadratic up into 12x squared plus 24x minus 7x minus 14, which when we bracketed was 12x squared plus 24x minus bracket 7x plus 14 bracket. Then we were able to factor out. As always, thank you for watching. I hope this has been useful. The whole purpose is to help people and to make things clearly understandable. So if you enjoyed this, give it a like, and please feel free to subscribe, as I'll be producing more videos regularly. Thank you very much.